Hi everybody. I've had some requests to explain some of these questions you've had for your assignment. And one of them is this question from the explanation assignment, the first one. So this is your explanation question. So it says A, B, C, and D are four identical corks floating on water. So waves travel from left to right, and the up and down motion of each cork is simple harmonic. And the first one is, at the instant illustrated, describe the motion of cork A in terms of its speed and direction. Okay, so A is at equilibrium, and then you know that at equilibrium, the speed is the fastest. So it's going fastest. Now you wonder, now is it going down or is it going up? Now this is how you're thinking. This is your wave. And the wave is a progressive wave. So it's actually moving forwards. So this part is already past A. This is the one that's coming, approaching A. So which way is A moving? It's on its way up. Okay, so that's how you say. So it's A is moving upwards on its way up. So this blue line is actually the wave that's going forward. And what happens is the wave's going forward. These particles go up and down in simple harmonic motion. This will become even easier for you when we start waves. So that's what it is. Okay, then the next question I had was from your assignment, the pink sheet, and that was question 2. So to explain question 2, so I'll just go through all of 2 because I had different queries from different people. So we'll come to your part in a while. So this was the question, boat on the tide. So the diagram shows a boat moored across a wharf at high tide. The tide causes the sea level and therefore the boat as well to move up and down in simple harmonic motion. The position of the deck of the boat has been shown at high tide. That's position H, H for high. Mid tide is position M and low tide is position L. High tide happens at 11 a.m. and you can assume the period of the tide is 12 hours. And then you got to calculate the amplitude, and then you got to say at what time will the deck of the boat be at the mid tide position. Okay, so we'll just do those 2 first and then move on to the next bit. So that's the wharf. That's where people step off the boat to get onto the land. So that's the pole that's supporting the wharf, and there's water. So there's your sea or river or whatever. And this red thing is the boat. And what happens is in the sea and oceans, the level of the water doesn't stay the same. When the tides come in and out, the water level goes up and down in simple harmonic motion. So the water level, the distance between low tide and high tide is 4.6 meters. So the amplitude is half. So that is 4.6 divided by 2, and that's how you get 2.3 meters. Now at 11 o'clock, it's here. They want to know at what time will the boat reach there. Now we also know that the period is 12 hours. So the time it takes to go from up to down and back again is 12 hours. So from here to here is quarter of 12. So 12 divided by 4 is 3 hours. So if this is 11 o'clock, and then you add 3 more hours to 11 o'clock, you get 2 p.m. Okay, so the boat will be at mid-tide at 2 p.m. So that's what that is. And then the next part is here. So Sarah was fishing off the wharf. As the morning progressed, she noticed that the deck of the boat moored across the wharf rose higher and higher as the tide came in. At 11 o'clock, when the tide was the highest, the deck of the boat was exactly the same level as the wharf, and then it sank lower and lower as the tide went out. The diagram shows the displacement reference circle for the motion of the deck of the boat. Point A shows where the position of the deck was at high tide. So there's point A on the top. And then what we have to do is mark point B for low tide and mark a point C where the boat would be 1 hour after high tide, And then we have to calculate the distance the deck drops, must be the boat, between high tide and noon, okay? Or the deck of the boat, okay. Okay. One sec, I'll better stop that.